Hi everyone, it's Miss N. We are in lesson 3 now, and we are going to talk about rational and irrational numbers today. The goal is to understand what a rational and an irrational number is, and we'll be able to identify it by the end of this lesson. Some things that we're going to do is we're going to express a repeating decimal as a fraction. We're going to estimate square roots to the nearest hundredth. And we're going to compare and order rational and irrational numbers on the number line. And then we're going to estimate the value of expressions. Okay, so all we're doing for the most part is we're estimating today. So let's take a look at what a rational number is. It says that rational numbers are numbers that can be written as a quotient of two integers. That means, where have you seen the word quotient before? We remember it from division, right? So what this is basically saying is rational numbers are numbers written through division of two integers. So what we're doing is we're taking the ratio, okay, that's why they're called rational numbers. And then since the bar in a fraction represents division, every fraction whose numerator and denominator is an integer or a rational number. So let's take a look at this number right down here. Okay, what this is saying is you have your numerator, you have your denominator. This fraction bar right in between your numerator and your denominator is what divides these two integers. That means that when you divide these two integers, you should get an answer. And that should be a whole number, okay? So you're just dividing a whole number by a whole number to get another whole number, okay? Or you can just simplify and write this whole number instead. Okay, so any number can be written as a fraction whether we have a numerator and a denominator, okay? So let's take a look at these integers and these whole numbers and these natural numbers, okay? All of these numbers here, they are rational numbers. That means that I'm putting them in ratios, okay? Remember from 7th grade, we learned that ratios is when we have a comparison between one number and another number, okay? And that's what we're doing here, is these are all rational numbers because they are ratios. Fractions are also known as ratios. So we can write our integers and whole numbers, okay? Integers are our negative and our positive numbers. Our whole numbers are numbers like 3, numbers like -5, numbers like 0. Okay, our natural numbers are just us counting straight from 1 to 2 to 3 to 4. Okay, there is no 0 in there. Those are our natural numbers. Our integers are both positive and negative, and our whole numbers are all of these numbers right here. Okay, so 3 equals 3 over 1, -5 equals 5 over 1, and 0 is nothing in our numerator over 1. And the square root of 25, we know, is also known as 5 squared. Remember, when we say square root, we are squaring the original number in order to get the number beneath the square root to begin with. So we can say it's 5. Or we can make that a ratio and we can say it's 5 over 1. The square root of a perfect square is also a rational number, okay? Same goes for a perfect cube, okay? But we're gonna look at square roots first. So the square root of 1, that means 1 squared is 1, okay? The square root of 4, the original number is going to be 2, so 2 squared equals 4, okay? The square root of 9 is 3, because 3 squared equals 9. And the square root of 16 is 4, because 4 squared equals 16, okay? The next point I want to make is that every terminating decimal is a rational number. That means any number that doesn't repeat itself and it stops somewhere. You see where this 4 stops in 4/10, this 5 stops in the hundredths, this 6 stops in the thousands. This 4 again stops in the tenths. Okay? It stops. It terminates. It's a rational number. Okay? We can also put these decimal numbers, we learned this in 7th grade, into fractions. We can convert them back and forth. We can also do this with percentages. but we'll look at that later. The next point I want to make is every repeating decimal is a rational number. So not only do we have terminating decimals where the numbers stop, but repeating decimals where this bar means that it repeats itself over and over and over again. So this is actually 0.333333333333333 and so on and so forth. I can go on forever, but I only have 15 minutes. So when we have something that repeats itself, that is also a rational number, as long as it ends up, this is the most important part, as a fraction, okay? It has to be in a ratio form. If you can convert this 0.33333 into a fraction, that means that you can change it into a ratio, okay? Here's another example. 512 hundredths and the 512 thousandths repeats itself. So it's 0.512, 512, 512, 512, 512, 512. It repeats itself over and over and over again. But I know that I can put that into fraction form. See here where it says x equals 512 over 999s. Okay? That means that this 512 thousandths just repeats itself, but we can also put that in a fraction. So again, a repeating decimal is also a rational number. Okay, so let's think about that for a minute. Okay, what fraction is equivalent to 5.1? Is 5.1 a rational number? Let's explain, okay? So let's take a look at what 5.1 is. 5.1 is 5 and 1/10. We can convert this 5.1 into a fraction. And since 5 1/10 is the same as 50 1/10, okay, that means that we can put this mixed number into an improper fraction and it still would be a fraction. And if it's a fraction, we know that it's a ratio. So 5.1 is a rational number. It is a terminating decimal and can be expressed in quotient of 2 integers. Okay, so it can be expressed as a fraction and it's a terminating decimal. It stops at 1/10. All right, let's take a look at another example. Let's explore it a little bit more. Okay, up here it says what numbers are not rational. Okay, so we've learned a couple rational numbers. Let's look at a number like the square root of 2. The square root of a number that's not a perfect square, okay? So there's nothing that I can multiply together to get 2, okay? Here I can multiply 1 times 1, or we know that as 1 squared, and still find the square root of 1. They have a relationship with each other. Same goes for here. 2 times 2 equals 4. I can find my square root of 4 and my answer is 2, okay? So let's take a look at number 2. It says, look at the number line below. The number square root of 2 is between 1 and 4 because we know square root of 1 is over here, square root of 4 is over here. Okay, so it makes sense that the square root of 2 is somewhere on this number line right here. Okay, since the square root of 1 equals 1 and the square root of 4 equals 2, that means that the square root of 2 is between 1 and 2. When we draw our point on the number line, we're going to locate the square root of 2 by drawing it on here, okay? So let's calculate first, okay? It's going to be around 1.3 because we know that it's between 1 and 2, and we know that it's like right close to where we first start counting by decimals in our number line. So we're going to square 1.4, and we're going to square 1.5. 1 and 5/10, 1 and 4/10, 1 and 3/10. Okay? So these are our answers. We have 1 and 69 hundredths, 1 and 96 hundredths, and 2 and 25 hundredths. Okay? Based on our calculations, let's draw our point. So we're taking this 1 and this 2 and whoop, we're making it bigger. Okay? And we're just magnifying our number line. So right in between, this is about the halfway point. This is 1.5, okay? So where would 1.2 fall, or where would our square root of 2 fall? We know that our square root of 2 is right around 1.4. Okay, so it's right around here as I magnify it even more. We're just estimating right now. Okay, so let's calculate. 1.41 or 1/4100 squared equals 1 and 9,881 10,000ths. We know that 1 and 4/200 squared is 2 and 164 10,000ths. Okay, so what I have to do is figure out, based on these two calculations, where is that square root of 2 going to be in between? Is it going to be in between 1.1 and 41/100ths or 1 and 42/100ths? All I'm doing is I'm making this number line even bigger to magnify it. So I know that the square root of 2 is going to be right in between 1 and 41/100ths and 1 and 42/100ths. Okay? So number 8 says you can continue to estimate getting closer and closer to the value of square root of 2. For example, 1 and 414 thousandths squared equals 1 and 999,396 millionths, and 1 and 415 thousandths squared equals 2 and 2,225 millionths. But you will never find a terminating decimal that multiplied by itself equals 2. The decimal will also never have a repeating pattern. So what this is saying is, when I find the square root of 2, and I know the bigger number I make it, because we started off at 1.4 up here, okay? And I'm adding a 1 to 1.4, okay? And I'm adding a 2 to 1.4. And no matter how big, now I'm adding a 4 to it, now I'm adding a 5 to it. No matter how much bigger I make it, that number is not going to change. That number is always going to, it's not going to repeat itself, and it's not going to terminate itself, okay? And that's how I know that it's going to be an irrational number. The square root of 2 cannot be expressed with a terminating or a repeating decimal, so it's not going to be written as a fraction. We're not able to do that because the number will not stop going. It's kind of like pi. Remember we talked about pi, and you talked about pi a little bit earlier during the school year? We said that pi is a number that does not repeat itself and it does not terminate. That means it's an irrational number. I can't put this number in a fraction, okay? So again, ratio means, rational numbers means that I can put a number in a ratio. An irrational fraction means that I cannot put pi in a fraction. That's why we call it pi. Okay? It's such a special number that we have to do it that way. Wrap up our lesson. This page on page 27 says, let's talk about it. You can estimate the value of an irrational number like square root of 5 and locate the value of the number online. Remember what we've talked about so far, okay? We're going to determine whether or not the square root of 5 is a rational number or not a rational number, and where we would put it on our number line. If it's not a rational number, we're going to estimate it to our nearest thousandth or wherever we can estimate it to. So once you calculate everything, we find that the square root of 5 is not the same as our square root of 3. It actually repeats itself over and over and over again. It does not terminate and it does not repeat the decimal. Okay, it's an actual number and it goes on forever. The calculator itself says the square root of 5 is 2.236067977, and that's just to estimate. Once you copy down your answers, we will go over the next pages in class.